this idea of an internet for everything, right?
Yes.
The industrial internet. But you guys are really starting to gather massive amounts of data on what?
Well, it's on the performance of the machines that drive heavy industry. And it's really about driving productivity for our customers. Greater productivity in how they use the machines, but greater productivity in their operations.
And these machines are not like bulldozers or something. We're talking about jet engines, wind turbines.
Gas turbines, we're talking about MR machines, CT scanners, all the things that GE makes in the heavy industry. Rail, mining, aviation, healthcare, and so on.
Well, they're giving you feedback already all the time as to whether they work or not when they stop working. So why not try to capture it earlier? Is that the idea?
Well, I think it's to capture more. I think in the last decade, what we've seen is devices are becoming more intelligent. And I think we're really on the cusp of something transformational because companies are looking for greater productivity gains.
But that's always been the case. I mean, I worked at GE, and there were all these lean initiatives and always trying to sort of squeeze a little more juice out of the lemon.
But you know what's changed is the technology is there to actually get the intelligence to the machine. Before, it wasn't. Cell phone technologies have brought down the cost of putting processing, putting sensors in at prices we couldn't even think of before. And I think that's one of the big changes. So this is a real opportunity to take advantage of that technology.
So what's the scale that this is operating at? You know, nanosensors in every little piece of equipment that's put together, every little part, or?
I think what we're going to see is hundreds of sensors. But even today in our gas turbines, jet engines, we got, let's say, 20 sensors. And those 20 sensors, when you look at each one, so for example, just monitoring a blade on a gas turbine, we're capturing about 588 gigabytes per day of data. Times 20 sensors, times our fleet at 12,000. So we're talking about really big data.
So I would imagine the infrastructure to crunch that data is something that even GE has never seen before.
I don't think anybody's seen it, and that's what we're finding. Now, we are working with a lot of the key vendors, especially here in Silicon Valley, to give us the infrastructure. Where we're finding that we have to put our time and energy is actually in the analytics to do something with the data. Because by itself, that infrastructure doesn't have a lot of value. The value is, can I predict that something's going to break long before it does, and then instead of having unscheduled maintenance, go to scheduled maintenance. That's what it's really all about.
So there's a lot of software work to be done in sorting through that data and highlighting the real intelligence in it.
And that's right. And I think that software is becoming just as important as the mechanical engineering side of the device.
Wild. It seems to me also that the way that you're using this, you're going to be gathering data all the time, not occasionally, so that it's one of the rare uses of these massive amounts of computational power that might make your own sense to have your own data center instead of use an Amazon Web Services or a Rackspace or something.
You know, I think it'll be both, to be honest with you, because I think we certainly will have some for our own, but the fact is that when you start working with the customers, they'll have their own clouds, private clouds, as well as that you're going to want to use the public cloud for certain kinds of things. Now, with that said, security, regulatory considerations, all that's going to come into play here in a big way.
Why regulatory?
Well, how you control the data, who can see the data. You have to protect that. You've got to protect that customer, you've got to protect the individual.